Hello friends, I'm Shishir Kumar. Welcome to my channel From Darkness to Light. From today, I'm going to talk about binary search tree, and I'm going to write a simple Java program via recursion, and then we'll explain how internally in memory stack the logic is working, how the recursion is going to work in Java memory stack. So let's start. So first we need to know what are the properties of binary search tree. So in binary search tree, every left node key of the tree is going to be less than or equal to the parent node key. And in right side of the node key is going to be greater than or equal to the parent node key value. So that's the property of the binary search tree. So let's see a very simple example of array and its representation as a binary search tree. So this is a simple array having 7 elements, and if we see the tree which is formed is a binary search tree, because like let's go to the left. So left side is 14 is lesser than 25, 8 is lesser than 14, and let's check the right side condition. So this needs to be greater than the parent node key. So 15 is the right side, which is greater than 14, but we also in binary search tree, like all the nodes which is left to the parent key, which is let's say 25, everything which is left is needs to be less than 25. So 15 has to be less than 25. So it is true for every node of the left subtree. Let's check the right side of it. So every node needs to be greater than 25, so which is true. 30 is greater than 25, 20 is greater than 25, 45 is greater than 25. Let's check for 30. So 30 to 28 is going to be less than 30, and 45 is going to be greater than 30. So that's simple. Now to write a simple Java program via recursion, let's just first we'll take a very simple example, just having 3 node into the tree. So, and the recursion program which we are going to write is to check the property. So let's say if there was only one node, which was the parent node, so it has to be lesser than a certain key. So that's what from property or like from recursion which we are going to write. So for the left boundary condition to begin with, for the root node, let's pick it as a lowest value of the integer, which is minimum value of the integer. And the right side, let's take it as a maximum value of the integer. Now, like we will do the recursion first for the left side of the tree, and it will keep on going into the recursion. So first it will go for 14, and then keep on doing till it finds element into the left. It will go to the right, then come back out of the recursion, and it will do this same validation for the right side of the subtree. Let's write a simple Java program, and then we will fill this stack. And I have given a different color code so that we are easily able to understand like at which particular node it is at, and what is the input which is coming into that particular method. So basically which logic of the recursion is right now in memory is being worked or validated. Okay, so this is a simple method signature is BST. Now let's to start with like first we need to check the boundary condition. So let's say if we have our node has reached to uh, the null, so which is it is the leaf node and the value itself is null. So then definitely like we it is a binary tree, because we are going to fail the moment it is not adhering to the property of the binary search tree. We are going to fail. So that's where if it reaches to the null condition or the leaf node, so it is returning as a true, so that it goes into the right side of the recursion and validate the same. So let's write the negative logic against which it has to fail. So all it is same. So we are saying node which is coming, its data is less than the left side. So then it has to return false, or if node dot data is greater than right key, then it has to return false. Definitely, like we need to, this is just for the current node which is coming as an input, but we do have to keep on doing this recursion for every subtree. So which is simple. So now we have to do first do this for the left side of the node, and here for the left side definitely like left key is not going to change, but the right side is going to be the parent, right? So node dot data, and we have to also validate the same condition for the right side, which is going to be, and here the left condition is going to be the parent, right? So, and right key is going to be the same. So this is what, let's just format it so that it looks nicer. Okay, now I'll just wrap it into a simple method as BST, which will just take an input of root node. So we are not mandating that whoever is calling our method doesn't needs to pass the left side and right side of the condition. So they will just pass the root, and this will take care of this public method, or like will take care of calling this internal method. So right now everything is static, so I'm not going into that loop of optimizing the program, just focusing on logic. So root, and here it is going to be integer minimum value and integer max value. Now let's print the outcome. Okay, so if you see right now, I have just taken a very like 3 node, and it is the BST. So our output should return true. Okay, cool. It returns true. Let's swap the node so that like now it is not a binary search tree because it doesn't meet the property. So it should return false. Let's validate. Okay, cool. Let me reverse and make it to the binary search tree. We will fill the recursion stack, and then we will also validate like if our recursion understanding is correct or not. So how it is going to happen? So first it will go to 25. For the left boundary condition, it is integer minimum value of the integer. Right side is going to be the maximum value of integer. Then it will come to the left. So for left, it will take, it is now validating the node which is having the key value as 14. The minimum value is going to be the same, which is coming from the last program of the last call of the recursion, and the right side is going to change, which is going to be now the parent. So 25. Now it will again come to this null. So here now it is validating null, It will validate against integer minimum, and here the right side is going to be 14. Though it will return from the very first logic which we have written, if node is equal to null, so return true. So we don't need to do any validation, but this is how internally in recursion the values will be coming. So here the left side, because it is for the right side, right? So this null value is coming. So the left condition is going to be 14 and right condition is going to be 25. Now again, it has like covered all the leaf nodes which are null. So it will go back to 25. It will go to the right side, which is now 30th, and we will just fill our stack. So 30 is going to be the input. 25 is going to be the left side, which is the parent, if we see here, and the right side is going to be integer.max. Now again, this left leaf will be called into the stack. It will be null. 25 is going to be the left side. 30th is going to be the right side because the parent is 30th, and it is doing the left side of validation. Now the for right side, null is going to be left side is going to be parent, right side is going to be integer.max. Let's check this. So we will go back to our program. We'll just write is this out println, and let's print node data, and let's print node. I'll override the toString method so that it is printing the data value or the key value at the node. Left side for comparison, and let's print the right side of the comparison. Okay, now let's just I'll just quickly override the toString method. Okay, it's a bit slow. Teacher dot. It will handle the null pointer. So if it comes null, so it will handle. So sorry, this dot data. Now let's run this program again and see our understanding about the how it is working in memory, how the memory stack is working is correct or not. Okay, so first 25 is coming, integer min max, then 14, right side becomes the parent key, then the null, right parent becomes 14, and then like the right side of the leaf node, here the left side becomes 14 and 25. So let's validate. So that's for this one. So left side becomes 14, left side becomes 14, and right side becomes 25. And same for the right side. So that's how the internally within the recursion is happening, and the methods are getting called into the stack, and then it comes back and returns true. So thanks for watching my video. Please share your comment, subscribe to my channel, and let me know which video you want me to make on. Thanks for your time.